All right, everyone. Welcome back to our next talk. Today, or now, we will hear Exploiting MCP Servers in AI Workflows by Yotam. And enjoy. The stage is yours.
Thank you. So, hi all. First of all, great to be here. First time for me at Troopers. I've only heard good things about the conference, so for me it's exciting to be here. A bit about myself. So I'm Yotam. I currently lead security research at a startup, an AI security startup based in Israel. Before that, I led research teams at Zscaler, PayPal, and a few other startups in the cybersecurity space. I've been doing dealing with a bunch of stuff from vulnerability management a lot of years. I've been involved in industry work groups around SBOM, VEX. I'm a member of the EPSS SIG. And I've been dealing with AI security before it was cool, you could say, when it was ML security, adversarial examples on vision models. So for me, it's an exciting time now to be in the space where we are actually seeing real-world impact for the research. And today, as the talk entails, we're going to talk about MCP security. So who here knows what MCP is? Okay, so the vast majority. And who has experience in using MCP servers as part of his work, hobby? Okay, so pretty much most of the room, which is great. Just to set the stage, this is a scenario when let's say you're in an airport, and I'll soon be, and your flight is delayed. Hopefully that won't happen to me. And you want to get some work in. You open your laptop and start working with your favorite coding agents, and you have an MCP server or servers that allow you to interact with Jira, with your source control, etc. So that's exact scenario in which someone on the airport Wi-Fi network can send a single HTTP request and basically either get access to all of your secrets or execute code on your device. So, and that's kind of the scenario that we're going to talk about today and show real-world examples of vulnerabilities that we found that allow that. And like the show of hands kind of exercise that we did here, MCPs are becoming an integral part of everyone's life, basically, in our space. They're becoming super popular because they allow utility. They allow AI agents, LLMs, to take actions on our behalf and become more useful. So this is just one of the vulnerabilities that we discussed is in a server that was downloaded over 4 million times. And the thing is that the attack chains that we'll show, they don't require any sophisticated phishing chain or malware or some kind of special user interaction or even prompt injection. I'll talk about it. It's way more straightforward. Yeah, so won't spend too much time here, but basically an MCP server is kind of like a glue between our agent, our LLM, and the tools that we have on our machine. We can interact with it over the network in various ways, either through a CDIO or HTTP and SSC, which is actually not recommended, and it's also deprecated in the protocol. I'll touch about that in a bit. And then through that, we are interacting with the MCP server, and each MCP server basically has tools that it makes available for that interaction. And so just a note about streamable HTTP or HTTP plus SSC transport. So Streamable HTTP is now the recommended way by the protocol to actually interact with an MCP server. As you can see from, it's been for a while now, from November 2024. But still, the majority of servers that you'll see in the wild in terms of their default configuration and how they are used, they still use kind of the old, not recommended way. The thing about the target that MCP becomes, it's a lucrative target because it often has access to tokens in order to authenticate and use these tools. We provide it with outbound access, again, in order to interact with the different platforms. It can have file system access to take actions on our behalf. And usually, or I wouldn't say usually, but a lot of times, we also use it to perform kind of automatic tasks or workflows that require higher privileges. And this is just for it to do its job, right? There's nothing wrong with that. That's just the way things are. But the repercussion of that is that if an attacker gains control or is able to influence the MCP server, then he gains or she gains a lot of power in the process. There's a specification. It's actually pretty live, and there's a new there's work being done on it. It's improving, but the specification is also very permissive. Like it doesn't enforce a lot of things. There's a lot of shoulds in the specification. So in this case, in terms of authorization, then the spec says that you should use authorizations, but it's optional. It's not something that you must do. At the end of the day, it comes down to the implementer, to the person building the server and deploying it. And that's where a lot of the problems actually stem from. And another kind of common thing that we see with these MCP servers is that they're often deployed open to the network, to the local network. That's the optimal scenario. Sometimes it's not only to the local network, and I think that's also some kind of conception that it's a productivity tool. It's for my environment, for me to be able to perform action as a developer, but this again assumption often opens the door for devastating attacks, basically. And just as a reference, this is a research from Trend Micro from April, so not like early April, I think, not too long ago. So these are servers that they found exposed in the wild. A lot of them, out of the 1,400, 1,200 are using the legacy SSC server, which I said was deprecated for, or not recommended to use for a year and a half-ish. And a lot of them have access to tools like execute SQL queries, execute file system operations, etc. And this is actually, there's another research from Census, also from the end of April. They reported much higher numbers. So they basically, through the course of 2 weeks, they saw a jump from 12K servers to 21K. So I assume the truth is somewhere in the middle, but just to get a sense of how common is a phenomena in which these servers are open to the public, basically. Obviously, the security community is not blind to these risks, and there's a working group in OWASP that I'm also a member of that trying to define best practices. There's a lot of documentation and research around it, and OWASP issued the OWASP Top 10 for MCP servers, some I think late 2025. There probably should be a newer version released later this year. So as you can see, we have token mismanagement, secret exposure, tool poisoning, which again, I'll talk about a bit. In a bit. Command injection and execution, insufficient authentication and authorization, shadow MCP servers, so servers that are running that are not governed basically in the organization. Privilege escalation, supply chain attacks. A lot of the things aren't really unique in the cybersecurity space, just manifesting in this ecosystem, et cetera, et cetera. And so for us, again, as a startup in the space and as a research team, I kind of wanted to drill down into this area and see like in retrospect, how bad things are. I wasn't expecting that it will be that bad, but these are kind of the things that keep surfacing. The two vulnerabilities that I'll discuss here are just a glimpse of a much broader research that we haven't released yet, but we found a lot of interesting stuff, you could say. Fail open issues, we'll see an example of that. The binding to 000 that we discussed. DNS rebinding, which I won't talk about in this talk, but it's a mess in terms of how many servers are vulnerable to DNS rebinding, breaking the trust boundary breaks before the handler. So this is what I'm trying to say here, that you have the MCP tools that are usually, that's where the more scrutiny is applied in terms of vetting, like what the tool can do. Is it the scope of what do I allow it? But what you'll see soon is that a lot of the breakage comes even before the tool. So it's, and then it doesn't matter because the tool does what it's supposed to do, but on behalf of the attacker now. SSRFs, path reversal in file tools, things that are, again, not novel, not innovative, but they simply exist because it's new, because people don't still, the best practices are being written as we speak, and that's kind of the result. And again, before I'll dive into the examples of what we found, I want to make clear that this is not, an isolated case of a single vendor that got things wrong. This is a much broader phenomena. This one is an example that I like. It's actually a research from another Israeli startup called Oligo from, let's say, June 2025. And this is MCP Inspector, which is an Anthropic project, and they should know what they're doing, right? And it had no authentication, open to the network, vulnerable to DNS rebinding, eventually allowing to run RC on the machine that's running the server. So if they got it wrong, then you can imagine that thousands of other servers downstream got it wrong too. This is another one from JFrog, also an Israeli startup, but just not, maybe I'm a bit biased, but that kind of came up in the research. So again, the same kind of thing. This one is MCP remote, basically an MCP server that allows you to interact with remote MCP servers. Another 9.6 CVSS vulnerability, and again, allowing basically to take over the host that runs the MCP. And there's another kind of complete form of attacks that I won't get into in this talk, which is where a lot of the research, at least initially, lived, which is attacking the model. So we have attacks like tool poisoning, where you where you mess with the description of the tool, or you create, typo squatted tools that have the same name and then different functionalities. A lot of prompt injections. When the MCP interacts with an external resource, then it gets an attempted prompt injection and can do actions that we didn't intend. So that's like an entire layer of MCP server vulnerabilities that you'll often hear about and see. This talk is not focused on that, even though we found a lot of those as well. I'm focusing on much more basic stuff and basic security hygiene. So again, and this is again just to see that this is widespread, affects a ton of highly mature organizations, and not just random MCP that someone like there are problems there as well, but it's not just that that someone wrote overnight or vibe coded, right? As I was saying, there's kind of these two different planes, you can say, of attacks. One is the model plane. How do I trick the model in order to get it to do something that wasn't intended, or again, and this is something that I won't focus about. But there's a much more fundamental plane, which is the one that we'll discuss today, which is basic security hygiene, I could say. No, you don't need no social engineering, no model in the loop, no prompt injection, nothing like that. And the reason that the basics are becoming critical in these kind of scenarios is exactly because of the utility versus risk tension. So the more useful my harness, my agentic infrastructure is, the more risk it introduces. So when I have a standard bug, but a capable agent that has access to production tooling and can do actions on my behalf, then every standard bug can become basically an infrastructure compromise. So this is the flow of a standard MCP request lifecycle. So we have the transport layer that we discussed, hopefully authentication, and then we get a session. There are dependencies that the tool uses, the MCP server uses, and then once we have that session, we can invoke the tools, and those tools have access downstream to perform the actions on our behalf. Again, I talked about it a bit, but where a lot of the problems are in this section, not in the handler, not in the tools. There are issues there as well, but actually the more scary stuff is here. This is exactly what we'll see. And the point that, again, the tools are doing what they're told, but you no longer control them. And there are two basically ways that this boundary can break. One is there's nothing to break. There's just no authorization, no authentication, and you can simply invoke the tools if you get access to the MCP server. And surprisingly enough, we see that a lot. And there's the second option in which you have some kind of authentication mechanism, but the way that it's implemented isn't airtight, and you can find ways around it and override a lot of the security mechanisms that are in place, and then you get the same result, basically. So, first example is a vulnerability that we found in a project called MCP Atlassian. So it's not the official MCP server from Atlassian, but it's much more popular than the official because they took their time until they released an official one. By the way, there were vulnerabilities in that one as well, so it's not, I don't know which one is better, but this is the one that we looked on. It's basically it's a pet project from a PhD student in Asia that got super popular, 4.4K stars, as I said earlier, like over 4 million downloads. And what we saw there. So it starts with, again, the basic primitive that, as I mentioned, we see a lot. The HTTP server runs exposed to the local network. It has like a personal access token that the memory holds. And then the server basically supports multi-tenancy, in which the client passes the target URL for the Atlassian server as part of the HTTP header in the request. Again, to make things more easy, more useful. And then once you pass that, then that's the server that the MCP will interact with. But the problem is, and this is the first vulnerability that we discussed, there's no validation as to what that header is. So this is basically the code. As you can see, we're taking the header from the request. This is the name, x_Atlassian Jira URL, and put it into this variable. No validation, no whitelisting, no allow list, nothing of that sort. And then from there, basically, that becomes the URL that the MCP server uses in order to fetch information from the Jira. And here, we have an authentication with the personal access token of the victim. But now it doesn't matter, because now the only thing that does is that I'm now able to take actions on behalf of that user in the privileges that personal access token allows. So that was the first kind of issue that we found. And then that wasn't all. So now, just to make sure that we're clear, the attacker can change the header to whatever server he wants, whatever host, and the request will go to that attacker-controlled server. Basically, this is how it looks like. So all I have to do is provide like create a simple post request to that MCP, define my attacker control URL, some kind of authorization token. It doesn't matter. It just needs to be valid. I don't think it even has to be valid because, as we saw earlier, the code hard-coded the personal access token into the authentication flow, so it's not really being used. And so again, super simple, and the server is basically now an SSRF proxy, so I can interact with it, sorry, the user interacts with the server, but it actually interacts with my attacker-controlled server from inside the network in which the MCP runs. And that basically allows you already to access internal services, and again, using the same token that of the victim. So whatever that victim has access to via the token, I can, as an attacker, access. And because this is kind of an agentic system, then I also get this harness that I can use to actually perform actions that are more sophisticated and flexible using that same token. Okay, so that's the first vulnerability that we disclosed. But it turns out that there are a few tools, and this is usually the pattern. So the first stage is getting a way to interact with the server, and then you're basically depending on the tools. If you see interesting tools, you can do interesting stuff. Sometimes the tools are are, you know, all, I don't know, all read like only have access or the possibility to read things, or so it's not really interesting. But as soon as you see interesting tools, like in this case, upload attachment, then I can basically exfiltrate whatever file from that host that's running the MCP, and that information will make its way to my server. So ID RSA, AWS credentials, basically whatever I want. But we didn't stop there, because we said, okay, exfiltration is nice, but let's see if we can get to a point where we can actually execute code. And we found that as well. So it turns out that there's an additional tool that's called Confluence Download Attachment that we can use. And it basically fetches any attachment from the server. And because I can control the URL, I can specify a path that I can write into. So what we can do with that is basically write to a path that already exists, run over it, and then simple examples are bash RC or whatever shell configuration. And the next time that that shell configuration will load, it will load with my input. And then, obviously, from there, it's game over. So, again, nothing here like we had to work super hard to identify, to circumvent. We simply used what was given to us. And that's kind of the scary part. So as I said, next time the configuration loads, I have access to run code, either as root or if the user, like in the permissions of the user, basically. So that was the first vulnerability. We disclosed it a couple months back. It was patch. We had actually the challenge was getting in touch with the maintainer. So he had other PhD work probably that he did, and he wasn't available. Eventually, I tracked him down through LinkedIn. I sent him a message on LinkedIn, and then he replied. And then, but once we got in touch with him, it was solved pretty quick. I think in a week or 10 days. But that's kind of the kill chain that we used. So several different bugs that we can chain together to get interesting impact. Yeah, and that's the disclosure process. Yeah, so 2 weeks, basically. And so we added a function that validates the URI for SSRF protection, and another one for the safe path, so we can't run over any files. As I said earlier, the problem here is in the middleware. It's in the layer that is between the host and the MCP server. Once that isn't tight, then from there there's not really a lot of work that the attacker has to do to create impact if the tools of the MCP allow it. Okay, second vulnerability. This one is in a project called Nginx UI. So it's basically a UI layer that allows to manage Nginx server. Again, super popular project, over 10K stars, 430K pools of the Docker containers that run it. They, at some point, apparently, you know, from a user request, their own initiative, added an MCP server, and that was the downfall, basically. Because the project itself is in pretty good shape in terms of security. So what we found there, again, missing authentication as the first step. How it played out is, it was interesting. So basically, you had two endpoints that you can interact with. One with the MCP itself, where the authentication was enforced. And the second one was MCP message, which is actually the interface through which you interact with the tools. You invoke the tools. And this one simply had this function missing. Once you don't have that, then basically, again, okay, there was another mechanism that could have prevented it, which is an IP whitelisting. So we say, okay, we don't have authentication, but we can define a whitelist, so only IPs from that whitelist can interact with the server. But the problem here is that if you keep that list empty, which is the default, because you don't know what to define there, then it fails open, meaning that an empty list means everything is just allowed. So for everyone running the default configuration with no, that didn't define any IP whitelisting, then that safe mechanism was also bypassed. And again, we just walked right through. In this case, the MCP has 12 different tools that it exposes or exposed at the time. I think now maybe there are more. 7 of which were destructive. So again, once we are able to interact with the server, all we need to do is discover it. It's a default port, like not rocket science. Then we can interact with it and trigger these tools. So what we did here is basically, again, posting through the unprotected endpoint. There is authentication, again, that we need to go through at the first stage to connect to the MCP, but there was actually a different vulnerability that I won't discuss here that was present at the time that we did the research that allowed to gain access to that. It's called a node secret. It's a local secret that's on the machine in a constant place. Like it's not really well guarded. So we were able to also circumvent that because, again, there was another vulnerability that was fixed by now that by the time that we reported, someone else reported it before us, but we took advantage of that to pass kind of the first layer, and then from there, there's not much to bypass, actually. And again, so now we get to the tool layer. So what are the interesting tools that we found here? So as I said, the Nginx UI allows you to manage the UI, like a UI, like an user interface layer to manage Nginx servers, and it has a tool called Nginx config add. And that tool calls os write file and basically allows you to write to the configuration directory of the Nginx UI. So once we can do that, we can rewrite the main configuration of the file, of the server. This is the tool. And then also the other nice part about it that we don't have to do anything after that because the way that it's configured is once you do a configuration change, it auto-reloads. So the changes apply like instantly, which is also nice. How does it look like? So this is kind of the Nginx UI. Let's see if I can, how do I trigger this? This? Yeah, okay. So this is the Nginx UI running locally in this case. So you see there's a user, there's an admin user in this case. And then I run the POC. It's from a different IP on the network. One is 0.2, one 0.3. These are the tools that are exposed. Some are only read tools, but some are dangerous tools. And now, basically, I inject the configuration from the attacker machine, run over the existing configuration, and then open the browser and the port, and voila. So this obviously wasn't there before I interacted with the thing, and we can see if we go to the configuration management, then we see the conf file that I injected. And here, basically, I can do whatever I want. Once I have access to that, I can configure whatever I want. So what we can do. Now there are various ways to kind of to take it to the next level. In this case, what we found is that we can use the configuration in order to set up logging. So the next time that an admin interacts with the, was the user, interacts with the Nginx UI, the JWT gets logged, and then as an attacker, I again can access it, and then I can use the JWT in order to authenticate as an admin. I can do a GET request to an API that's called settings, and then once I do that, the entire secrets are plain text. So it's not. We're getting now to the cluster secrets. So this is a basic, privilege escalation path. That from here, from the MCP server, we went to the Nginx UI, and from the Nginx UI, you can now take control over the Nginx servers that are running on the machine. So it's pretty crazy, and yeah. So this is what I just discussed. So we went from arbitrary file write, able to run over the configuration. We were able to steal secrets from the admin user, and then using that, we can take over the entire cluster. And that's just one scenario out of many, because again, once you have the ability to run over the configuration of the Nginx UI, basically, it's game over. So what we saw here is kind of a lot of things that are not unique to those two projects. We're seeing it a lot. As I said, this is just a glimpse. We have a lot of other vulnerabilities that we're kind of in the process of coordinated disclosure, which is long, but the patterns are the same. So we have some kind of security layer, or we don't in some cases. But in the case that we do, it's often not tight enough, not enough validation, not enough thought put into threat modeling the MCP server and understanding what can happen if an attacker is able to get access to those tools, and basically that's the result. For the second vulnerability that I discussed, so we also did kind of a quick showdown search for Nginx UI using the favicon. We found almost 2,700 servers that are publicly exposed. This is not mentioning the ones that are running in local networks that are also vulnerable. And basically about less than 2 weeks after we reported the vulnerability, after the fix was applied, we saw exploitation in the wild. So not only us, it's Vulncheck added it to the Vulncheck Kev, and a bunch of other vendors identified exploitation in the wild of the vulnerability. And the fix was super simple, right? If you remember the line that it's just adding the authentication required. Like, it's not overly complex to fix, but still today also you still have a lot of vulnerable versions of this server running around that are still vulnerable to this thing. And actually when I was, so yeah, this is what you just saw, actively exploited in the wild. And actually when I was working on this presentation, then I stumbled across this Reddit post that says, if you're using, this is from 20 days ago, I think it was 2 days ago when I stumbled across it. So if you're using Nginx UI, read this post immediately. Sorry for my non-professional English. I'm writing this in a very hyped mood. I'm not that type of Reddit user who's writing posts every day, but I just discovered something that could be affecting you in this very exact moment, in bold. I was trying to log into Nginx UI today as I noticed something is off, SSH to the server to discover I had sessions open from a different IP address. I was investigating the issue for almost an hour. When I got to see the config files and logs in the Nginx UI, then I found this. So basically, exactly what I described, CV2026, OPD, RBD, conf, basically a configuration file that wasn't there, that an attacker created. So if you take one thing from this talk, make sure that you don't expose your servers to the world, because attackers are constantly targeting this layer. Basically, it's not just MCPs, but MCPs is one avenue. So yeah, that was it made me smile when I saw that. Like I'm sorry for the guy, right? But it's just yeah. So and on that note, so it's important to note that the capabilities transfer, the controls don't. So what we saw with the second vulnerability is the Nginx UI was properly configured. The Nginx servers could be as hardened as you get. But once you have that MCP layer that is not tight enough, you can, cascade all the way. And this is, again, a pattern that we see a lot. And yeah, even if you have control, a lot of the times they're not good enough, or the fail open instance that we saw earlier. And again, I mentioned this, but the reason that this becomes more critical is because it allows the attacker to very easily get to a point where it can have significant impact on the environment just by being able to interact with that MCP server, because the server is meant to enable actions on the environment, privileged oftentimes. So once you have that, it's like living off the land in a way, but on steroids, because also the tool is very powerful, and then if you have like an agentic harness around it, then it becomes even more powerful. Even if you don't have that, then a lot of times you can use that to pivot within the environment and gain additional access or create more significant impact. I would divide kind of the takeaways to three different audiences. So if you're writing these MCP servers, even for your own personal use, make sure to do some reading. There are best practices. There are bad practices that you should avoid, a lot of them. Oftentimes, it really is just a matter of awareness. As you saw, nothing here is super challenging to implement in terms of making it more hardened. If you're deploying these MCPs, then be aware that these things exist and are targeted in the wild, and make sure that you vet and validate your security posture around this specific layer. If you're a researcher, then like for me, I think what was interesting to see is when the MCP servers came out, there was a ton of talk about prompt injections and tool poisoning and tool squatting, and everyone was focusing on that layer. And I was like, okay, that's interesting, but it was covered. So where can I poke to find things that that maybe are not yet explored? And just that mindset and focusing on the layer that before, for me, it was interesting. I learned a lot, and I was able to find some really nice findings. So if you assess these things, even from a bug bounty perspective or from an internal security auditing, so make sure that you explore the entire life cycle. I started with this, but I'll end with it as well. So none of these issues that we just discussed are new. These are classic standard bugs that we see. We used to see in the past a lot. Now in standard infrastructure, we see them less. But here, because it's new, because again, people are not yet fully aware, we see them a lot. But the impact is much more significant. They are and they will be targeted by attackers in order to create impact, because attackers always go for the weakest link, and at this point in time, this is one of the weakest links that we have as an industry. So yeah, just be mindful of that, and I'll end with that, and I mentioned it, this is just kind of the tip of the iceberg of what we're seeing and what we already found and what we're in the process of finding. There's an entire class of DNS rebinding that we basically every second or third MCP that we hit, we see that they're vulnerable. So we'll be releasing additional research on that topic. So stay tuned. Welcome to follow me, connect with me on X, on LinkedIn, and would happy to take any questions.
Thank you very much for this talk.